Yeah, you'll find that in internet exchanges, you can do direct peering, or you can peer directly, or you can peer at an exchange. So where you find that SPs typically to one another, typically via a switch. And so they exchange this reachability information. So if someone has a resource and they want it to be reachable over the internet, so they will need to tell other autonomous systems that this is how to get to this resource. It could be a website, it could be cloud instance, and so much more that can be shared over the internet. So in order for this reachability to happen, the network administrators managing these networks will need to configure this routing protocol, and it uses the path vector algorithm in order to get to where this resource was announced that it is domiciled at. So there are a couple of ways that network administrators usually manipulate the attributes of this protocol in order to make sure that at the end of the day, that these resources are reachable. So I'll proceed to DNS. Given that we have talked about IP address, and there are quite many, it is really hard to master all the internet resources by their numerical IP address, whether it is IPv4, IPv6. So in order to make life easier, there needs to be a way to translate these numerical addresses into human readable and easy to memorize addresses. So that's where the DNS comes in. So generally known as, or it's just like a street term, the internet phone book. So what happens in the phone book is that the IP addresses gets translated to domain names so that users who want to access these resources in the internet will be able just to type the domain name on their browser, and the DNS will do the translation, resolving it to an IP. And finally, the routers will route this IP address to the destinations. So I also have a simulation for the DNS in order for us to understand what the cache or the stub resolver, recursive, the roots, top level domain, and authoritative. I will run the simulation so that we get to see how this process looks like. So I'll start the simulation. Resolver, typically it's what your computer will cache after a visit to a site. So you initiated request to a site, then that IP to domain mapping will remain in your computer. But what happens when now you are visiting a new site, so you don't have that cache? When you're configuring, let's say, your server, most of the times you will tell hosts which address that they should be using to resolve domains to IPs. You will configure most of the times 8.8 or code 1, 1.1. So that is the recursive resolver. And what the recursive resolver will do is that it will check the top level domain. Who manages this? If it's a .com, if it's a .net, if it's a .org, or if it's a .ke. So with that, it will send it. So it will ask the root server for it to give it a response to who manages these TLDs. So then it will send a request to the TLD for it to get a response about who is the authoritative name for this domain. Then the request will be sent to the authoritative server for it to respond with the IP. So that is the flow. Let me do the simulation again in a slow motion. Yeah, so that is the DNS process. I'll also share this. There are a couple of Linux commands that are down there which you can play around with to find out. You can try to resolve addresses and to find out who is the TLD of certain domains and so on. There are different types of DNS records. Most of the time we deal with the A records, but so for IPv6, you have the code A records, so resolving IPv6 files. You can have ones for mails. You can have simple ones as text. So most of the time, these simple ones are used within local setup within just your LAN. But you can find that they're also in the other resolvers that help in providing other information. Earlier, I talked about TCP, IP, and OSI. So given that this is the standard that these interconnecting devices understand. So with this standard, these interconnecting devices from hosts, servers, computers, and so on will be able to know how to put information together for the next device that is supposed to process this information to understand and respond appropriately or to forward appropriately. So from layer 7, we have the application. So that is where most of the time, that's where you are when you're opening your web browser, your mail application, and so on. You want to access a certain resource. So that's where you will be. And so once you've submitted your resource, the data that you submit, once you submitted your request, the request that you submitted will be converted at the presentation layer. So depending on what the application expects. So that's why you'll have data processing, formatting, encryption, and compression. So if you're dealing with a web page, it will be HTML. If you're dealing with an API, it will be JSON. If you're dealing with maybe a file server that expects images and documents, that's where presentations are handled. So once you have submitted your request, there need to be an establishment of an end-to-end session with the host that you are trying to connect to. So under this layer of the OSI, so that's what happens. It establishes ground rules for that session. And when the session is over, it does a graceful teardown. Then your data packet will go to the layer 4 of the OSI. So under that stage, so the end host are establishing which method should we use to communicate. Is it via TCP or UDP? So TCP, you'll find it mostly in web applications, UDP in voice applications or real-time applications. So once they have decided to establish a transport session, then you go to the network layer. So on the network layer, that's where you find the routing happens. Now that a session has been established and also the end-to-end tunnel has been established, so the data is handed over to the router, and the router will inspect the destination address where you want to forward your packets, and the router will check the destination. So if it doesn't have the destination address on its routing table, it will forward it to the default next hop that it has in its routing table. And in order for it to do that, so because the router is connected to another router at layer 2, so it will resolve the next hop IP, find out how it can reach it at layer 2. Then it will encapsulate that IP packet into a frame and forward it. At the physical layer, so that's where we have the physical medium. So in short, for physical layer, you think of things that you can touch or maybe see, because the reason I say maybe see, because you can see a fiber optic cable or you can see laser signal, but you can see radio frequency that is used to transmit packets at layer 1, or rather bits at layer 1. So this is all of the OSI model stacked together. So that's what you have, that's what you get. What I've just explained is put in a diagram over there. So I'll wind up with, as I hand over to Moses, 2 simulations, one for the BGP process and another for Starlink. Yeah, the reason I wanted to include Starlink is because it's common nowadays, gaining popularity. So it's good to demystify what really happens. Where are these devices? Are they on Earth? Do you need fiber still when you have Starlink? Is it still necessary? And such kind of questions. And also for BGP, what happens at an exchange and what happens when you do peering? And also, what are some of the things that a network administrator does in order to influence how data traverses from source to destination? Let me start with this. Yeah, there is the BGP simulation. So you can see that in my case, I am in the autonomous system 65002. So with this is the IXP fabric. So typically a switch where other interested peers can connect to and you can establish a session. And with that, you exchange routing and reachability information. And this one here is a private peer. It could be at an agreed location, data center, and so on. And so there are a couple of other things that you can play and think around. Because of time, I won't be able to capture all. So you can see that I have disabled packet flow by messing around with BGP. And now you enable. So with that, for example, just a quick one, if I'm withdrawing this prefix, it means it won't be able to be reached. It's telling a friend that is no longer my number. Don't call it. So with that, you won't be able to be reached. So in the case of the internet, this example is like a Google resource. Those who are resolving their domains or at 8.8 will have connectivity problems because they'll no longer be able to resolve addresses. So I'll share all these simulations. And so here it is for Starlink. This is you connected to that Starlink router that is facing space. And what's in space is a constellation of space stations that are orbiting the Earth on the low orbit. So between 50 to 400 kilometers above the Earth's surface. So when you send a request at home, it goes to the space station. Your packets will go hop by hop all the way until they reach the terrestrial data center. And also you can see in this simulation that the data packets are not symmetrical in the paths forward and reverse path. So yeah, that's what you need to at least be familiar with on the Starlink. Yeah, so because of time, I will share all these simulations and I will hand it over to my colleague Moses.
Okay, Geoffrey, thank you for the new information. Share your range of foundation for networks and how will you communicate. So here I'll be presenting on how the web really work and what really happens and we will do email and emailing, how that work. Generally, yeah, when you pull your web browser, you want like Chrome or Firefox or Safari, yeah, searching something. So you either search a word or you search an address. For example, you're asking your way somewhere. So in this case, we are thinking of an internet with a very big network. Then inside the network, we have what we call the worldwide. In this case, it's something like a city. Then in a city, we have some small buildings. Then inside those buildings, we have some rooms. So in this case, when you talk about the World Wide Web, it's something that when you type the address, the browser asks the computer, do you understand this address? No, I don't. Please, can I ask my internet provider, do you have any information about this address? Yes, I have. Where is it located? You will direct your request where the server posting the information for iPhone. Then once the server has been located, then the information that you are looking for will be given back to your browser. And then at the browser level, you let it use information from the browser. So in this case here, the browser just starts, and then the backend part is all that Geoffrey has mentioned, the ISP, the IMAC address and all that. If I touch out the emailing part, there are some terms that we need to understand here. Things like OPRI, things like the IMAP, and then what do they mean and where do they really come in? So, for example, when you open an application like the Outlook client, rather than the Gmail client, you type an email, then you click send. Then there's something called SMTP. So you think of it as like somebody is delivering an email to John. Then where is John living? Let's say block XYZ. Then after that one has been delivered, then there are two ways you can get that email. One way is using the of which is the POP3. So POP3, what happens here, once the email is delivered, you go collect the email and then you don't have any evidence of whether there was email delivered. But now the modern way is that we are now on your mobile device, on your laptop, email setting, essentially when it's interacting with APIs. Allow me to touch on the cloud, just briefly, what it is and what does the cloud now. So the cloud in this case, Geoffrey mentioned about the network and what the network entails. So in this case, we provide that with the cloud input services, things like the Amazon, we have Microsoft Azure, and then I think we have Alibaba. So the cloud here is in simple way, might or might not be, it depends on how you look at it. Like they say, we don't want to guys configuring all these things, setting servers, setting operating system on your own. We want to get these things for you 24 hours and 365 days a year, which you can guarantee that one. And then maybe you can be able to have it on the cloud. And then in these cloud service providers, they do offer several services, which is software as a service, PAS, and then I get it. Currently, we have PNC. We just get the Airbnb app, you look through what Airbnb unit can I get with what amount, then you pay the amount in advance, or you pay once you arrive and then you utilize units and you move out. So SAS is something that is within the cloud. So think of it something like the Google Docs that we mainly use here, the area of a problem solution, and then you get that and pay for that service. Then there's something else called the platform as a service. Think of this one like in a real estate setting, whereby you have a piece of land with some pretty big, even there, like a brick, something like, let's say, maybe some metal or other pillars are given there, just the small items that you may need for foundational timber construction. Then that's what as a service. And then the owner of that land tells you, okay, you'll pay me rent for the land and as well for the timber and the bitumen you find there. Then please bring on site your engineers to build the house however you want it. Then there is what you call IAF, infrastructure. So in this case, go somewhere, still in the real estate, you given just a plain piece of land. Then you told on this land, I'll only charge you for the bare land. Bring on your bricks, you're able to bring your metal, you're able to choose whatever brand of tenants you will use. And then you build whatever you want and however what you want. That's it. Then let me just introduce a bit of cybersecurity and what to and what not to. So there's some terms here that you may need to know, or rather something like a malware. If you can remember, 2021, we went through the COVID period. So in this case, if you talk about a malware, like what was the solution for the COVID virus, what you had put on a mask and all that. So in this case, in a cybersecurity setting, a malware, the ransomware that runs across the network, so that one Trojan that has been sent to your machine, then it affects almost all your information or all of it from the system. You need to have an antivirus and then avoid unknown download. And at least nowadays we have more intelligent browser that we can get. We are thinking that we're downloading this one. We suspect that it might be something not good. Do you think to keep it, or rather should we block it? So most of them they do block until you tell them please resume. It's something that try. It's something like phishing. Phishing can be either in email format with very convincing messages and the typing information. that can lure you into either clicking addresses like this amount is being won. If you click and share, you can be able to maybe the lottery and all that one. What is the solution for that one? Don't create any storage strangeness that you may encounter. First of all, confirm and verify whether it's an authentic. And there's something in regard to your password. What you need to do with your password online, you need to have strong password. And use the password when they want all your application password into one package, and then you connect the master key to that. And then nowadays we have cafes, we have hotels, with Wi-Fi, and everybody, anywhere they are, they want to be able to. So what you need to do in that case, if you connect to the public Wi-Fi, kind of use a VPN, which is a simple way like putting on a protective gear just to shield you from the outside world. It's like driving on a car, but they don't really know who is in that car. But at least when you're having a VPN. So with all this information that we've been mentioning about network and all that, so many things, we are thinking of a future whereby you are home, the gate online, and then you can be able to communicate to each other. For example, they can even be able to detect, or even today, your schedule, and then your first action will be, let's say, going to the shower. Then the shower gets ready for you. Maybe just warming the water and all that. Maybe before you get to your car, the system can as well be able to tell the car, please for us to leave home. So IoT opens a very big space for the devices that we are having nowadays, be able to communicate with each other and be intelligent in a way that they can be able to share information and get more data from what we do interact with them on a daily basis. There's a common thing that is coming up nowadays, AI and machine learning, which is something that everybody talks about.
Sorry to interrupt you. Just a polite reminder that we should be wrapping up to allow a few of us either go for late lunch and start putting their afternoon in order.
Okay. So one of the last items that edge network, we came to edge, we came to 4G, and now we are 5G. And maybe, who knows, maybe there's still no limit for that one. It's one of the areas that is really opening up for fast internet connectivity, especially in mobile connectivity. And then we have Web3 and decentralization. So the main point for Web3 is the remove the centralization of information. So maybe, Geoffrey, you can touch on the summary.
To summarize, so every device in the internet will need a unique IP address. This IP address, for it to be reachable, there needs to be routing. So there'll be like GPS. How do we get to these destinations? So the IP addresses will need to be translated, or there needs to be a DNS to translate domain names to IP address so that we don't have to keep a memory of many numbers. And so also the internet, given that it's big, it's subdivided into autonomous systems, and each autonomous system has their own routing and security policies in order to deliver internet service to their clients or customers. The autonomous systems will exchange routing information so that the internet can be one large contiguous block. Yeah.
As we wrap up and as we wait for the chapter president, on behalf of the Membership and Outreach Committee, I just want to thank Geoffrey and Moses for volunteering, creating this time to teach us about internet and how it works. In a different forum under the Kenya Network Operators Group, one of the best known engineer in this space actually said that it's never too late to learn how the internet actually operates, even for a seasoned engineer like him. And just listening to both Geoffrey and Moses, it was a very good reminder, those various cloud platform offerings, SaaS, PaaS, and being reminded on how BGP works, how routing works, how DNS works. So this has been an excellent, and Geoffrey, Moses, thank you so much. For our participants, delegates, thank you so much for creating the time to be part of this, for still hanging on even after we exceeded our allocation by 20 more minutes. Thank you so much for being part of this. This will be a series of webinars by ISOC Kenya chapter, mainly awareness training. So please expect more sessions. Be on the lookout, join the chapter, and importantly, I know next week we'll also have some sessions. As some of you might be aware, I will also be celebrating the Global Encryption Day at some point next week. And the ISOC team has a lot of activities, both for university students, for practitioners. So please be on the lookout for that. If you have ideas, areas you like to collaborate and work with ISOC Kenya chapter, please feel free to reach out to any of our ISOC leadership here. I'm just going to share my email on chat that you should be able to reach out to me and share your ideas. And the team is always happy to collaborate. SG is also here. I'm sure Howie you'll also be keen on how we can leverage the rest of the community just to ensure that we are using the internet as a multiplier for good. We have seen the digital transformation, job creation, and how the internet has made the world a small, a global village. My SG Howie, I'm almost running out of words.
Thank you. Thank you. Thank you. Amir, one of the things I want to thank everyone on behalf of the ISOC Kenya chapter, membership, and the executive committee. The next series of the webinar will be on encryption, and the next one also, we are looking forward to bringing community networks together so that we can discuss about how can you be able to start your own community network. And I think that's a very touchy discussion. And also Kenya, where we are moving, we talk about digital superhighway. I think that is always the very important thing to bring on the table. So I believe and I thank all the participants and everybody who has gathered here today. Thank you so much. Be on the lookout. Join ISOC, learn more about what others are doing, and let's keep on growing our society. Thank you so much. Back to you, Lawrence. Thank you so much.
SJ, thank you. If it's okay with you, I would like to close the session. I believe you have also shared the sentiments from the chapter president in your remarks.
Asante sana.
Thank you so much. Let's all have a lovely rest of the day, and we see you next in our next session.